this is Point on Pally here, and I'm doing something a little bit different at the start of this video. Uh, this video was actually supposed to be part of part 5, but everything started to run a little bit long. Part 5 is going to end up being over 3 hours long, so I just decided to split up part 5 into 2 parts. So part 6 now is its own video. I know at the end of this video it's going to say this is the end of part 5, but this is actually part 6. So in this video we go over creating a wave effect on the front of the Aku character here, and we also go over automated animation cycles for the tentacles to kind of give a pre-made walk cycle to the character. So if um, enjoy the video. If you like the video, please like, subscribe, uh, comment if you want. Keep the channel going. Thank you very much. Like the results that we've gotten from everything here, so at this point I can almost declare the tentacles done. You know, there's still a little bit more there's still one more thing I want to tackle with that. But I want to tackle one thing on the lower body before we tackle the last thing I want to do with the tentacles. And what I want to tackle here is this area right here. And one thing I wanted to attempt here was a kind of wave setup with this front portion here. When I first looked at this character and I saw this front part here, my first thing that I thought of was the character from Monsters, Inc. I believe her name was Roz. I have seen that movie 1,000 times and I would have never guessed that name. But she's the monster working the desk that is always kind of grumpy and always interacting with Mike Wazowski. But when she moved, I noticed this almost like slug movement with the lower body, with this kind of wave effect, where as she moved, there was this kind of rolling wave that would go across the bottom of her body. And I wanted to kind of mimic that or attempt that here. So I had thought of multiple ideas, and the one that kind of worked for me was I wanted to use a deformer, in this case a sine wave deformer, going across a curve that will affect the geometry. Now, the first thing I want to point out is this is all going to be done on a duplicate geometry, on a blend shape. And that blend shape will be applied to the original. Just because this setup is going to have pretty unique weighting when it comes to the quadrant joints here. So I wanted to have the setup on a separate blend shape, so what's going on here won't affect that. And since I've already split off the head geometry, so if I find that here, there it is. So I've already split off the head geometry, so I'm going to use all of this for like the facial blend shapes. So there's really not going to be a whole lot of geometry in the scene. So I'm okay with duplicating this geometry once just for setups like this. So I'm going to duplicate the geometry over here. And I'm going to move this guy over. It'll let me. There we go. And we'll call this, let's see, we'll call this wave B-shape geo, something like that. All right, so what I'm going to do here is I'm going to create a curve that kind of matches the front of the geometry here. Now, if you want to mimic something similar to this, and the geometry you're using is perfectly straight, then you don't really have to worry about this. You can actually just directly connect this setup into the translate of the sine wave deformer handle, and that would work just fine. But since this geometry is on a curve here, what I'm going to use is I'm going to use the curve and use a motion path to attach the sine wave deformer, and we'll get into all of that. So the first thing I want to do is create a curve to kind of line up with the geometry here. So what I'm going to use is a circle. Now I'm not necessarily going to use the circle for the curve, but what I wanted to do was use the circle as kind of a reference for how I'm going to create the curve. So let me actually go in a top-down view here. Alright. So I'm going to try and scale this down a little bit, move it a little bit forward. I want to try and mimic this setup, try and line up with the geometry as much as I can. So that's looking pretty good. And I'm going to up these sections to something bigger, like 48. Make the curve a little bit smoother. All right. Next, I'm going to go back to perspective view here. I'm going to go to display, NURBS, CVs, so I can actually see the CVs so I can snap on them. So I'm going to create a new curve. Now, if you wanted to, you could use this curve for the motion path. The only thing I would say there is the motion path is going to go all the way around the curve. So if you want a bit of delay on the deformer moving through this front part here, you could use this curve if you wanted to, because it would get to this point and then it wouldn't be affecting the geometry, and then it would move all the way around and come back. So if you want that delay, you could, if you wanted to, use this piece of geometry. However, I'm just going to create a new curve that kind of starts here and goes around. So I'm going to hide the geometry, actually. I'm going to make sure which CV I'm using, so that one right there. Okay. So I'm going to go to Create, CV Curve Tool. I'm going to make sure we're at cubic, and I'm going to start snapping to the points here. So holding down V, I'm just going to snap along these points. And there we go. I actually think we went one too far. Yep. All right. So there's my new curve. So I can actually get rid of the circle, and here's the curve that we're going to use. So I'm going to sort of pivot on this guy and move him up a little bit. So he's kind of right in there with the geometry. All right. Looking good. All right, so I'm going to call this, CT front wave path. All right, so the next thing I want to do is I'm going to create a duplicate, and I'm going to call this one the wire, and this one is actually going to affect the geometry via a wire deformer. And the path, I'm actually going to move slightly down, so this will be the one that the sine wave handle is following, and the wire is the one that's going to affect the geometry. So I can actually, let's apply the wire real quick. So we go to rigging, deform, wire. So we select the geometry, we hit enter, then we select the wire and hit enter. So now this should be affecting the geometry, which it is. So that looks good. So at this point, what we can do is we can actually create the sine wave deformer on the wire. So if I click the wire, we go to deform, nonlinear, sine wave. So at this point, what we can do is bring this down like that. Let's check the sine wave to see what it's doing. Alright, so that's the right axis. So now we just need to attach it to the path. So we'll select the path. Let's rename this. So we'll call this CT front wave sine handle. Now I'll select the path and then the sine handle. And we'll go to constrain, attach to motion path. I want to make sure we set the front axis to Y and the up axis to X. Let's see if that'll work. Alright, so that's looking good. We're going to break connections on the U value. That's going to create that cycle, and like I had mentioned before with, I think I had mentioned it before, the reason for the cycle. Maybe not. So the reason for the cycle is the add double linear nodes. And what I'll do is I'll select the path here. If I go to the node editor, these add double linear nodes are the problem here, because you can see this is where the cycle is happening for each of these nodes, where it's going, the handle is going into the add double linear and it's going back into the sine wave handle. And truth be told, we don't actually need these anymore. What we can do is directly connect from the coordinates of the motion path directly into the translates of the sine wave handle. So we don't actually need these add double linear nodes anymore. So I can delete these and just plug the coordinates into the translates, just like that. And you see it'll still be following the motion path, and now no more cycles. So that's a little tip for the motion path there. So at this point, I'm just going to move this like right into the middle here, and we'll turn the sine wave handle on. So you can see it's affecting the geometry here. Now, the one thing I noticed with the Monsters Inc. character that I'm referencing from, it obviously didn't go down because the character's on the floor, and if you have the down portion of the sine wave handle, then it's going to go through the floor. So we're going to turn off the low bound here. And so now you can see that we're getting the wave effect that we were looking for. Now, there's a few things. One, obviously, the wave effect here is pretty large. So what we can do is scale down the effect here. If we scale down the sine wave handle, you see it's lessening the effect. So looking pretty good. Let's turn this to 0. So the next thing I want to do is I want to take the weight off so it's not affecting the tentacles. I just want it to affect the front part here. So we go to deform. Let's go to paint weights, and we'll go to wire. So you see it's affecting the whole geometry here. So what I'm going to do is just select replace with a value of 0, and I'll just hit flood. So I take it off of the entire geometry, and I can just add it to the parts that I want. So I'm going to have add with or replace with a value of 1, and set the brush to the max distance, or the max, or the least drop off. And we're just going to paint this in. Something like this. Actually, let's get a little bit lower here. Like that. So this 5 point actually looks like a good stopping point. Or, yeah, so we'll leave that black. Stick to the edge loops here. Now I'm not reaching the ends, but you'll see what I'm doing. We're gonna smooth that so that it will kind of taper off and reach those areas. So we'll get to right about here on the underside. Like that. So what I'm going to do now is hit smooth, and then I'm just going to flood a bunch of times. So something like that. So now, if we check the sine wave path again, now you see when it reaches the endpoints of the curve, you see we're not getting the effect on the tentacles anymore. So we're getting the effect that we want on the areas that we want. So at this point, what we need to do is actually create the animation loop that will allow us to just basically run this on the timeline and not have to worry about it. So the way that we're going to do that is we're going to run an expression into the U value here. So to do that, we're going to open up the expression editor here. We'll go by expression name, and we'll call this CT front wave expression. And then we'll copy the name here, or we don't need the name of that. We need this name. And we can actually rename this too. So we'll call this CT front wave motion path. So we'll take this name and we'll go dot U value equals. Now here is how we're going to get that looping effect. We're going to I'm going to reference the frame, and we're going to use the modulus operator. So it looks like the percent. Now what the modulus operator is it's essentially the remainder of a division. So if you were to say divide the number 6 by 5, your remainder would be the number 1. And so what the frame is going to do is just reference the frame number. So if we say frame divided by 5, it will loop every 5 frames. So when we get to frame 6, 6 modulus 5 would be 1, 7 would be modulus 5 would be 2, 8, 3, 9, 4, and then when it gets to 10 modulus 5, there is no remainder, so it's 0. So it'll actually loop back on itself. So this is, to me, the best way to get that looping animation effect. So, but the number that we need here is actually the number 1, because the U value, the max, is 1. So we want it to go all the way to the end of the curve and then loop back. Now, the problem is, as you can imagine, there is no remainder when you divide anything by 1, unless it's like a decimal point or something. But since we're dealing with the frame, and the frame is integer numbers, essentially, it's just going to convert to 1 every single time. So what we want to do here is divide the frame by a specific number. And what the number is going to be is essentially how long do you want the animation to be. So if you want the animation to be essentially 2 seconds long or 48 frames, you would divide the frame by 48. And then that number you would take into the modulus of 1. So if you take the frame and divide it by 48, it will get to the value of 1 by the 48th frame, and then you'll get the remainder of 0, and then it will loop back. So if we actually create this and we run this, you'll notice what happens. See, it gets to 48 frames and then loops back in on itself. And the great thing is we can actually create a node and reference, or we can create an attribute or a node or something, and we can reference that attribute or node with this number. So you can actually create an attribute and connect it so if you adjust that attribute, you will adjust the length of time it will take for the animation to complete. So we could adjust it so we could say, it could take 8 frames and then it will run ridiculously fast. Or you could up it to, say, 120 frames. So it'll take 5 seconds. And the animation will go a lot longer. So that is what we're going to do. We're going to create just a quick attribute in a node setup so that we can adjust the time of this. What we can also do is create attributes to, let's say, increase the scale of this, so we can make the wave a bit bigger. We can increase it in length, or we can increase it in height. And if you wanted to, you could also add the low bound if you wanted to as well. So if you want to have that wave effect where it goes down, I don't see why you would do that. But just in case, if you did, you have that option as well. I don't think we're going to do that for here since this is right on ground level. It doesn't really make sense to have the low bound, but just know if you want that option, you can do that in here. And if you wanted to, instead of increasing the scale, you can increase the amplitude here as well. Does just about the same thing. In fact, we might do that instead of the scale. But, I mean, you can see here, increasing the scale does exactly the same thing. So, with that, let's get the attribute set up. So what I'm going to do is create an icon to place over here. And get the easiest thing to make sense, since we have a nice tentacle icon here for the master control, we're going to create an icon that looks similar to the bottom of the character here. So I'll just use this for reference over here. So we'll create CV curve tool. Should be cubic curve, but either way, so we can start here. Something like this. Create that little wave effect. That's on the front of the character. Something like that. Snap back to the original. Something like that, and just because I like to do this, I'm going to curve and I'm going to close the curve so that there is no open point on the curve. Something like that. And I can adjust this to make it look similar on both sides. Either way, we can do something like that. So, and obviously you can make this look however you want it to, but to me you get the overall idea of what this curve looks like. So let's scale this in a little bit. Something like that. So we'll call this CT lower body icon. And we'll parent this under the master control icon. And we'll lock and hide these attributes. Now we'll create some attributes. So the first thing I'm going to do is I'm going to create the icon visibility for these quad controls. So I have the ability to turn them on and off so that it's not so cluttered. So I'll do quad controls viz. We'll add the attribute. And then we'll create the separator. And we'll do front wave. The separators, I want to make sure that it's all caps. Front wave controls. Alright. So at this point, we can do, let's do wave height. So this will be how tall the wave gets. And we'll do 0 to 10. Then we'll do wave speed, or we'll do wavelength. Not one word, because we're actually doing the length of the wave. We'll do wave speed. This will affect the expression. Is there anything else we need for the wave here? I don't think so. No, I think we're good. If you wanted to, you can include the low bound here. It's up to you, but don't really need it here. Alright, so that's really all we need for the wave controls. So now we can start connecting the attributes in. So what I'm going to do here, let me just check something. So what I'm going to do is, let me break that real quick. So what I'm going to do, I tried testing the scales, but I want the ability to, when the attribute here is at 0, that I want it to essentially be off. But the problem with scales is you don't want to have a 0 for the scale, so we're actually going to connect this into the amplitude and the wavelength of the sine wave. So the easiest way to do that is we can use a set driven key for that. So we got the sine wave here, sine 27, and we'll use the lower body icon here. So we'll start with the height. So I'm going to turn the amplitude to 0. So we'll key it, and then we'll take the height, bump it up to 10, and we'll take the amplitude and we'll bump it up to a very high value. We'll do like 1.5. That looks good. Nope, 1.5. Alright, so we'll do that. Probably won't need to go all the way to 10, because I mean that is starting to look a little extreme, but always give the option to push it if you can. So we key it like that. There we go. So if we put it to something like 5, or even less than that, let's do something like 3. There we go. And now let's do the length. So the length will go right into the wavelength here. So we'll key it really low. Actually, never mind. Let's not use the wavelength. Let's actually use the sine wave handle here. So we'll just turn the scale to a really, really, really small value. That makes more sense. So we'll do scale Y. And we'll set it to like 0.01. Something really small. We'll key it. We'll bump it to 10. And we'll bump the scale to something. Let's do like 3. 3 might be a little much. Let's start. Let's do 2.5. There we go. So key it, something like that. We can lower, so we can bring it to like 5. That looks good. And next we got the wave speed. Now this one is going to be a little bit different. We can't just do a set driven key into the expression. So what we're going to do is we're going to create just a generic node, like a multiply divide or something like that, and connect this attribute into it. And there we will have it. Or we could do a set range node. Really, you know, the options are up to you. So let's bring in this control. And we'll create, let's do set range, because I love the set range node. So we'll do CT front wave set range, and we'll plug the wave speed into value X. So we'll do old max 10, old min 0, and we'll set the max to do 120. Let's go a little bit higher. Let's go 144, and we'll set the min to 8. So we obviously don't want to set it to 0 because then you get a divide by 0, which we don't want. So now that we got that, we can take this set range and we can say u value equals the frame divided by set range dot out value x. So if we create that, that should do it. So let's take a look. So right now, since the oh wait, I forgot to. No, I connected it in. So right now it should be running really fast because the wave speed is set to 0. So let's see what happens if I take this attribute and I increase it. You see, as I'm adjusting it, I can adjust the speed in real time. And that's it for the front wave setup. So with that done, I want to tackle one last thing for the tentacles before I declare the tentacles done. So the last thing I want to tackle here, let me just clean this stuff up. Get that in there. All right. So the last thing I want to tackle is I had this thought as I was building the tentacles, is I gave the ability to have kind of a walking tentacle here. So if I move these around, oh, I forgot to turn the skin cluster back on. There we go. So as I move these around, I wanted the character to walk. Well, my thought was, man, it would be really convenient if I could automate kind of a walk cycle for every single one of these tentacles. Give the ability to not have to animate all 13 tentacles, because that would be kind of a pain. I was thinking if there was a way that I could animate all of these at once, that would be really convenient. So my thought process was, could I take something similar to what I did for the front wave over here? Let me just turn all that off. Or I'll leave that on for now. So if I could take what I did for the wave, where I had something moving along a curve, could I automate that animation? So I came up with something similar that I think works here. So what I'm going to do is I'm going to have a locator moving along a circular path and connect the pad of this icon to that path to give me walking animation. It's going to loop almost the exact same way as here using the modulus and the expression. The only difference is, since it's a circular path, I'm going to set it up so that it stops at the half point of the circle. So it'll loop up and then stop here at the grid almost, and then move across and then go back up. So to kind of give that almost walking loop here. So let's go through this process and see what we get. So the first thing I'm going to do is, actually, I'm going to hide everything to start with. I'm going to take this entire group here and hide it, so we can work kind of independently here and not be too cluttered. So I'm going to create a NURBS circle. And we're going to bring it up to 90 degrees here, and we'll freeze transformations. And I'm going to take the number of sections here, and I'll up this to like 48 or something. It doesn't really matter. The number of sections make it a little bit smoother, but not by much. And it ultimately won't really matter, but I just like doing it that way. So if we're going to do this for, let's say, the first tentacle, I'll call this left tent 1 path. Now I'm going to create a locator. Create locator. And I'll call this left tent 1. I'll call this path locator. And I'm going to create a group for these. I'll call this left tent 1 path pad. And something very important here, with the locator, make sure in the attribute editor you turn inherent transforms off. Because what I'm going to do is I'm going to attach this locator via a motion path, and since the path is parented to this pad, the locator is going to move double. So if we turn inherent transforms off, then it won't have the double transforms. So now that I've got it under the pad here, I'm going to take the curve and the locator, and we'll go to constrain motion path, attach to motion path. Doesn't really matter any of the settings here. We can just stick to default settings. You can set it to scene up. The world up type really doesn't matter here because that is dealing with rotations, and we're actually going to get rid of them. So we can set it like that. And we can break connections on the U value here. Similar to what we did for the front wave, we've got the cycle here with the add double linear nodes. So what we're going to do is go into the node editor here. And we've got our add double linears. So similar to what we did before, we don't need the add double linears. We're going to hook the motion path directly into the locator here. So we're just going to take the coordinates and plug it into the translates just like that. And the rotates we can actually get rid of. So we can actually delete that connection. And we'll just zero out the rotates here. So at this point, we should be getting the animation. So that's working for what I like. Now you'll notice that when I get past 0.5 in the U value, it goes underneath. So I want to have the ability to stop it once it gets to that midway point in the circle. So what we're going to do is we're actually going to disconnect this. I just wanted to show you that it's working. And we're going to plug the coordinate X and Z into the translates. I'm going to disconnect the Y. So at this point, we should be getting the X and the Z value, even though those don't really matter. It's not going to really make that much of a difference here. In fact, if I move this U value, yeah, you just see it's moving flat. But if you rotate this setup around, then you'll definitely need those translate X and Z values. So what I'm going to do is I'm going to take the Y value of the coordinate and plug that into this setup. So I'm going to take the motion path here, rename this left tent 1 path, like that. And we're going to create a condition node. We'll call this left tent 1 path condition. And what we're going to do is we're going to plug the Y coordinate here into the first term. And we're going to say if the coordinate is greater than a specific value. Now, for the second term, which is going to be the limit here, what I'm actually going to do is I'm going to use the translate Y value of this path pad here. Because this path pad I'm going to be able to move around. Yeah, you see it's not moving. It's because of the translate Y value not connected yet. But what I'm going to use is that translate Y value of the pad as the second term here. So I'm going to bring that in. I'm going to plug the translate Y into the second term. So if the motion path value of Y is greater than the pivot of the curve, which is at the midpoint here, then we want to say it'll follow the path. If it gets less than the path, then I want it to stay flat. So we'll say if the value is greater than, color of true R. If it's less than, I want to take that translate Y value of the pad. So if the motion path value is greater than the translate y value of the pad, follow the path. If not, stay flat with this translate y value. So now we can plug that output R into the translate y value of the locator. So now if I adjust the motion path, you'll see what happens. The second it gets to that translate y value, it stops and it comes back to the original point. There, now we have the animation range that we're looking for. And the good news is I can move this pad around, and no matter where I rotate it or anything like that, the locator is going to stick to that path. So now that I have the range of motion that I'm looking for, the next thing I want to do is to be able to adjust that range of motion. Let's say I want to make the path the same length, but I want to make it higher, or vice versa. What we're actually going to do is create some nonlinear deformers, specifically the squash deformer. So if I increase the factor here, you see it increases the height. Now I don't want it necessarily to decrease the width here, so what we're going to do is take this expand attribute and we're going to turn it to 0. So now the factor is only affecting the height, the height of the arc of motion of the range of motion here. So I'm going to call this left tent 1 height squash handle, and we're actually going to create this another squash handle. We're going to rotate it 90 degrees, and now we have the one for our length. So I'm going to make sure we turn expand off, and now we have one for the length as well. So I'm going to call this one length. So I can actually take these, so I can say, oh, make the length a little bit more and actually decrease the height a little bit. I now have the ability to fully adjust the range of this animation. And no matter how I adjust it, if I move the motion path, you see it's still following the motion path exactly. So let's take these and zero out the factor. Now the one other thing that I want to address is, let's say I want to offset this. Since I'm going to be applying this to every single tentacle, do I want the tentacles to move in the exact same animation, like perfect symmetry, similar to the sine wave setup that we had before? Well, no, I want the ability to offset it. Well, the handy thing with the motion path is it goes based on the order of the verts. So the motion path will always start at CV0 of the circle. So in this case, right there. Well, luckily with the motion path is you have the ability, if I rotate the curve, it actually moves the CVs. It rotates the CVs. So this is how we're going to get our offset. You see, as I'm rotating it, it's still following the locator, still following the path, but it's offsetting the value. So this is how we're going to get different start points for the animation for each tentacle. So the tentacles are not going to have all the same range of motion. We can actually offset it by adjusting the rotation values here. And the good thing is, because we're using squash handles, is I can adjust the range here, and no matter what, the locator is still going to follow that same path. No matter how I change the range here, the locator is still going to follow the path, no matter how I rotate the circle, because of the deformer setup here. So, with that, we can actually start connecting stuff together. But before I do that, the last thing I want to do is actually create the animation based on the timeline. So what we're going to do is that similar setup that we did for the front wave, we're going to set up for this locator. So we're going to have it animate along this path. So if we go to the expression editor, so what I'm actually going to do is take the code from that front wave expression, and we're going to create a new expression. We're going to call this left tent1 path expression, and we'll copy this in here. So this is, I'm going to get the name of the motion path. Now, we don't have this out value yet for the node that we did previously, so I'm just going to just type in a generic 48 number to start with, but it's all the same principles. We're using the frame, we're dividing by the number of frames, essentially, that we want the animation to take place. We're doing the modulus of 1, because the 1 is the max value of the U value here. So if I create it, you'll see what happens. So there is the animation loop that we're looking for. And it doesn't matter where I move this pad. I'm going to make sure we parent the squash handles underneath. So it doesn't matter where I move this pad, or rotate it for that matter. This locator is still going to work. Now there might be a little bit of a problem with, the rotation. This is one thing I still need to work on, is the rotating value. However, to me, since we're doing this with like a foot control or something on the ground, you're typically going to want that value to be on the ground. Plus, if you need to adjust it, you can always actually like move the icon that is going to be following this setup. So it's not 100%, it's like 98% perfect if you did actually want to rotate the pad. But in reality, I don't think you would necessarily need to do that. So once we've got this all set up, what I'm going to do is bring this back down, and let's unhide the original rig here. Now what we can do is take this setup. I'm going to select the end control here, and then the pad, and I'm going to parent constrain with maintain offset, or at least point constrain with maintain offset. I'll parent constraint, something like that. We'll delete that constraint, and then we'll take the icon's pad here, so the pad right above the icon that shouldn't have anything on it, and we'll parent constrain it to that locator. Make sure maintain offset is on, or that it's off. Oops, other way. So I want the locator. So let's go to the pad in here. There we go. So let's select the locator, then the pad, parent constraint with maintain offset off. So now if I play the animation, we're getting that range of motion. And the great part is I can take this pad now, and I can move it. The pad of the setup here. Take this pad, move it in a little bit. So now we can get some of that bend in there as well. So I can take this. So we're getting a little bit bend. I could push it just a little bit more. So now we're getting that range of motion. And this pad can be adjusted how you want, but that's the range of motion that we're going for. And to show you that we can increase the length here of this squash handle, so I can actually make it longer if I want to. I could make it higher if I wanted to. But you can see that this gives us a lot to work with as far as the range of motion is concerned. So with that, we can now create an icon to control this animation value. So really we need, I'd say, we really only need 3 attributes. We need one to control the height, or 4 attributes. Maybe even 5. So we want the ability to turn this on and off so that the tentacle isn't following at all times. We want to be able to control the height. We want to be able to control the width or the length here. We want to be able to control the speed of the animation, and we want to be able to offset the animation starting point, how we did with the rotation of the circle here. So we need 5 attributes for this animation setting. Now, you could, if you wanted to, actually set it up so that you have, similar to the master icon, you have 1 attribute to control the speed of each of these tentacles, which we might end up doing anyway, because that, to me, seems to make more sense, because you are trying to edit these all at once. That's the whole point. So you're not animating these one at a time. So we'll probably just create a single master control here for the animation. And we might create an we'll create an offset attribute for each of these. So we'll have 1 attribute to control the overall speed, 1 attribute to turn it on and off, and then we'll have attributes to control the height of each of the tentacles, the length of each of the tentacles, and the offset of each of the tentacles. So we'll do that on 1 icon. So we'll create an icon for that. So let's create a quick control for it. So let's have some fun with this one. Let's create CV curve tool. So let's start 2, 3, and let's use the grid snapping here. All right, so there we go. There's our walking icon. So we'll call this CT walk animation icon. Inherit this under the master control icon. All right, so we'll lock and hide all of these attributes. That one too. All right, so we'll create some attributes. for this. So we'll start with the simple on off. So we'll say animation path on off. Then we'll create some floating attributes. So we want one for the speed. So we'll say, let's say 0 to 10. So we'll say path, we'll call this one path speed. There we go. And now we'll create the attributes for the width and length. So we'll call path height and we'll do, let's see, we'll actually do a minimum of -10. So we'll leave it so this is kind of like the default setting for the path. So we'll do left, temp 1, height. And so we'll go through and we'll create one for each height here. Oops. We don't want that. We want CT 1. And then we'll go right tent 1 height. Alright, so we got the height attributes. Now we need to create one for the length and then one for the offset. So I'll skip forward a bit before, so you don't have to see me do this the whole time. Alright, so we're back. We have all the attributes done. So I've got one for the on-off, one for the speed, and then individual level attributes for the height, the length, and the offset. So at this point, we can start to kind of key everything. We can use set-driven keys. Let me just make sure. So at this point, all right, so the one thing I think I need to do first off is I want to finish up oops, I clicked the hypership by accident. I want to get the node editor all completed. And specifically, I want to connect the speed into the expression. So this is pretty much exactly the same way we did it for the front wave. Is we're going to create a set range. We're going to set I'm going to call this left tent 1 path set range. And we're going to plug the speed into the value here. And then we're going to set the max to 10. And we're going to set the minimum to 8. And the new max to, let's say, 144. And then from there, we can take the set range and we can plug this into the number there. So out value x. All right, so that's all done. So we don't have to worry about that at this point. So the last thing we just need to do is we need to connect the on-off. So let's do that real quick. So the easiest way to do that is to go to the pad, go to this constraint, take this constraint and the icon here. We'll add these in. And we're literally just going to directly connect that on-off attribute to the target here, just like that. So that should turn it off. It would be nice if I could get it to go back to its default position. Alright, so what I might do in that case is create a default point here. Since I used the snap and just turning it off is not going to move it back to its original position, looks like I'm going to need an original spot here. So an original position locator or a group or something to that effect. So what I might do, let's see if this works. I'm going to take this locator, or the group, the top group there, because that position is correct. I'm going to parent it underneath the old group. I'm going to call this animation reference pad. So it's going to be separate from this pad here. And I'm just going to use this as kind of a default position. So what I'm going to do is I'm going to take the locator and this original pad, and I'm going to parent constrain it to this, to the original pad 1 that we had. Maintain offset off. And so at this point, we can directly connect into these, and it should send it back to its default position. So let's do that. So let's take the control and the icon. So now what we're going to have to do is we're going to have to create a set range node. You could also do a set driven key, that's fine. In fact, you know what? Let's do that. We have plenty of nodes as it is. Let's work with the set driven key. So we get the icon here, load driver. So when it's set to off, I want it to go to its original position. So down here. So let's select these two, key it. And we turn this on. Let's flip the reverse and hit key. Okay, there we go. So we have the on-off all set. Okay, so the last thing we need to do is start connecting the height, the length, and the offset. And this we can also do with set-driven keys, now that we think about it. So let's do that. So we need, for the set-driven keys, we need the 2 squash handles. And we need the actual squash nodes, which we can't get from here. Let's see. Alright, so what we need to do is go into the node editor, and we need to grab the two squash nodes. So 1 and 2, here they are. Load driven on these. Alright, so there are the attributes that we need. And the other thing is the offset. So you need these two things and this circle. There we go. All right. So for the height, it is, let me just double check to make sure which is which. So the height is 41. Oh, no, the height is 40. And length is 41. So height 40. So let's key this. So we'll key the factor at default. So let's move the height all the way up, and let's up the factor. Let's do 1, because there's no way it would go any higher than that. So let's key it there. And let's take the height all the way down to -10. And let's lower the factor as low as it can go to -10. So we'll key it there. Okay, so we've got the height done. Let's do the length. We'll key it at 0. Same. The length I may push a little bit further here. Let's go to 2 on the length. It's a little extreme, but I think it'll be alright. Oops, and I moved the wrong attribute. Let's go back before we do that command. Now let's move this to 2 and key it. And key this at -10. All right. We got the length covered too. Last thing is the offset. So what I'll do for this is we've got the rotate X here, looks like, of the circle, and this is left 1 offset. So let's key it, and we'll move this to negative. Oh wait, these I want to be offset, so I'll just edit this real quick and then we'll skip forward ahead after that. So let 1 offset. So this is -10. Close. All right, so we'll set this to -10, and we'll push this. We'll do -180, something like that. So we'll key it. Move this to +10. And move this to 180. And keep it. So now we can adjust the position. Like the full revolution around, we can adjust it however much we need it to. And it should still work regardless of the length. And the width, and the height. So that looks good. So we got it exactly how we want it. And then the last thing we need to do is just parent this underneath the master control icon. Check to see if we get any double transforms or anything like that. Nope. So that's looking good. Alright, so at that point, we're pretty much done with the animation path of the first tentacle. So I have the script that will do the remaining tentacles, and once I get that all set up and working, then we'll come back and we'll look at the finished product. And then we'll make some adjustments as we need to get a pretty decent walk cycle going. All right, so we're back. So we have the animation loop set up for each tentacle. It's the exact same process I did for the first one, so there's really nothing new here. They're set up so their position is right near where the original position of the end icon for the tentacle was. I just moved them all in a little bit so that you get a little bit more of the bend. And everything is connected to the main control here. And I've even adjusted the offsets. So these numbers will vary depending on what tentacle you're working with. But I set it up so we can get a pretty decent walk animation at this point. So what I'm going to do is hide these so you can get a sense. So if I turn this on, and again, don't mind the waiting there. This is just a test bind. But now, if I run the animation, you can see the kind of animation that we're getting. So the center tentacle, I rotated the path 90 degrees so that it goes, the path kind of goes inward and then out, whereas the rest of them are kind of going side to side. But you can see the kind of animation that I'm getting here. So we can get some decent movement here. And I can always adjust the speed if I think this is going a little too slow. I could take this to, let's do 1. This is probably going to go too fast, but you can get it. And I can always take these paths if I think they're moving a little bit too side to side or something to that effect. So I can take the tentacle 6 here and I can rotate it a little bit out, something like that. So now if we play the animation, now you see I'm getting a little bit more of a forward-backwards movement as opposed to the rest of them that are side to side. And, you know, I'm kind of trying to move them all together, like with just a little bit of delay on them. I was trying to mimic the Dean Hardscrabble from Monsters University movie with the movements, but you could always kind of have them alternating paths for each one, so you could do something like that. It's kind of up to you what you could do with them. If you wanted to, you could also include this animation on the quadrant controls as well if you'd rather have, you know, these joint systems moving. That could also work, or you could have them kind of moving in tandem, so you could set that up as well. But that's the idea I was going for with this. It came out pretty good. You know, I think this is definitely a good starting point for developing that animation cycle a little bit more. But I think we're getting some pretty solid results with the animation. So the last thing I need to do before I can officially declare like the lower body done is to just apply the wave deformer or the sine deformer, the front wave thing here, to the original as a blend shape. All right, so it's time to do the blend shapes. Now, I'll admit I went a little bit forward because I've run into a problem I've actually never run into before. I've been working with Maya in a rigging capacity for about 10 years now, and I still managed to find new errors, and this one kind of messed me up a little bit because I couldn't find any information about it, but I'll show it to you just so you can see kind of what I'm working with here. Let me turn the wire deformer back on. So this error, make sure the sign is back on too. Turn that off as well. All right, so this error happened when I go to apply the blend shape, as I normally do. You select the duplicate, then the original, and you go to deform, blend shape. I'll call it main body B shape, something like that. You default settings have it set to local. You can turn off check topology because if I select the head as well and select the original, and you set the deformation order to automatic so that the blend shape node will go underneath the skin cluster. So I hit apply. And at this point, you turn everything on. Now watch what happens when I select or when I run that front wave deformer. Watch what happens here. You see how it kind of cuts off here? Cuts off right there. I have no explanation for why this is happening. It's working perfectly fine on the blend shape model. There is no weights issue or anything because I just applied the blend shape. So there is literally nothing I could think of that was causing this problem. And I messed around with as many settings as I possibly could, and I eventually found a workaround for this. And it involves using the world as the origin. Now the problem with this is if I leave these models where they currently are, what this means is that the original model will now shoot to that position. So it doesn't account for the original position of the model and the values on them. So that's a problem. However, we can always move these back to the origin. And this has been the only workaround I've been able to find to make all of this work. So, and I want to test one other thing while I do this. So what I'm going to do is take the duplicate model here and then the curves for the wire deformer and all that. And I'm going to group this. I'll just call this wave offset. And I'll just move this -12 in X because that I moved everything to 12 grid units to the side. And the duplicate head geometry I'll just zero out. And at this point I can actually just take these and unparent them. Just bring them back into the pad like that. So it's perfectly fine. Right back to its original position. So now what I'm going to do is I'm going to select the wave blend shape geometry, the base head geometry for the facial blend shapes, and then the original body. And now I will run the same blend shape that I did before. But before I do that, I set the origin to world. So now when I run this, let's check it out. Now I didn't test it on the original model, I used a duplicate, but let me see if this actually works the way it's supposed to. So if I turn on the height here of this, let's see what we get. There we go. So I gotta be honest, this problem has never happened to me before. I've been using local for a decade. It's never been an issue. For some reason, of course, on this video series it shows up. But, you know, over the years in my time in education, I've always learned that Maya is going to find new ways to break your brain. And this was definitely one that stumped me for a little while, but we got it working now. So with that, I can show the wave deformer, or the front wave. I can turn on the tentacles here. And I turned the skin cluster off here. There we go. So I'm going to turn the blend shape geometry off for now. There we go. So we're left with the original. And so now you can kind of see everything working in tandem. So now you can, if I hit play here, you can see we got the animation going on the tentacles, and we have the front wave going at the same time. So we get a lot going here, but I think it makes for a really dynamic looking character. Gives a lot of life to the lower body. And I might include the animation on the quadrants as well. I'll test that just to see how it works. I'm curious to see what that'll look like. But I'm going to call this part of the video done officially. I know this one took a while, but there was a lot going on here. So I can officially call this done. And so we are finished with part 5. In part 6, we most likely be going into the torso rig here and getting into making this as dynamic and stretchy as the tentacles and giving a lot of life to the torso of the character. So on to chapter 6, and as always, please like and subscribe if you've enjoyed this video series, and I'll have a couple of the things I've done in this specific video I'll probably make separate podcasts for as well, so we can kind of keep some of the ideas that I've had here, like the animation path and the front wave here. I want to add those to their own videos as well, so if you're looking for information on that, you can go to that video too. As always, thank you.